Good morning, my YouTube viewers. It is Crystal here, and I wanted to give you another code review. This code review is going to be on a data set that has been loaded into Kaggle, and it's to do with hourly energy. And we're going to use XGBoost to predict on the energy consumption. So the first thing, this isn't a competition, but it's a data set. So the first thing we're going to do is we're going to read the problem statement, which is PJM Interconnection LLC is a regional transmission organization in the U.S. It is part of the Eastern Interconnection Grid operating an electric transmission system serving all or parts of Delaware, Illinois, Indiana, Kentucky, Maryland, Michigan, New Jersey, North Carolina, Ohio, Pennsylvania, Tennessee, Virginia, West Virginia, and the District of Columbia. The hourly consumption data comes from PJM's website and are in megawatts. The regions have changed over the years, so data may only appear for certain dates per region. So that's your problem statement. The next thing we're going to do is we're going to import the libraries that we're going to use to carry out this forecast. So we're going to import NumPy as MP, which is a library that helps you to perform numerical computations and also create NumPy arrays as well as linear algebra. And we're going to import Pandas as PD, which is a data processing library, and it helps you to create and manipulate data frames. We're going to import XGBoost as XGB, and XGBoost is going to be our estimator and make predictions. We're going to import matplotlib.pyplot as PLT, and what that is that is a graphics library, and it enables you to plot the data points onto a graph. We're going to import Seaborn as SNS, which is a higher level graphics library built on the top of matplotlib that enables you to perform statistical graphics. And we're going to import math because we're going to need that library to perform some advanced mathematical calculations. And we're going to assign our color palette as being color_pal equals SNS color palette, and the PLT style is going to be 538. The next thing, after we've imported our libraries, we're going to load our files. We're going to use the OS library to do that. It's going to go into the operating system and retrieve the files that we need. So these are the files, and we're going to use the pjmw hourly.csv file. So we're going to read the files. So data equals pd.readcsv, and then the Kaggle file, and then data.columns equals date time energy MW, data equals data.setIndex date time, data.index equals pd to date time data index data. So now you can see the index, which is the date, and the time is the index, and the energy MW is the only column of data, because the only column of data that they're going to use in energy in megawatts. So we're going to look at data info. So the energy is going to be a float. Now we're going to plot the graph. So data.plotStyle equals dot. Big size equals 15,5. Color equals color palette 0. Title equals energy time series. So you can see the energy time series. And then we're going to do a train test split. So train equals data.log 2002 1231 2014 1231, and test is data.log 2015 0101 to 2018 0102. And then we're going to graph that as well. And so you can see that the test file is kept separate from the train file. So the test file is orange and the train file is blue. One thing that you can see from this time series analysis is there's a lot of seasonality in the plotting of the graph. So that means you have varying levels of electricity at different parts of the day. So now what we're going to do is we're going to define a function to create our features. So data hour equals data.index hour, data day of week equals data.index.day of week, data quarter equals data.index quarter, data month equals data.index month, data year equals data.index year, data day of month equals data.index day, data day of year equals data.index day of year. And so now what I wanted to do was to just add a little bit of flavor to this function. I checked for Independence Day, so I set it up to where if it is Independence Day, then you get a marker of 1, otherwise you get a marker of 0. I did the same with Christmas Day. If it is a Christmas Day, you get a marker of 1, otherwise you get a marker of 0. And then I did New Year's Day. If it is New Year's Day, you get a marker of 1, otherwise you get a marker of 0. I will say that I spent about a day trying to figure out how to do Thanksgiving Day, and I did actually get the algorithm for Thanksgiving Day correct, but there's something wrong with the internal workings of Python to where some of the dates didn't come out correct, even though I got the algorithm correct. So I couldn't use it because my programming is not that good to be able to go in there and find out what the problem was, because it was to do with the built-in function. It wasn't to do with anything that I personally have done. So what I would need to do is I would need to do programming to program down to a lower level than what I'm currently programming at in order to be able to resolve that problem. So until my programming skills improved to that point, I couldn't put Thanksgiving Day in there, but I would have liked to have. I would have liked to be able to have a marker for is Thanksgiving. So that's the end of the function. So it returns the data. Data equals create features data. And so you can see data where we created all these columns. So instead of one column of data saying energy MW, you have hour, day of week, quarter, month, year, day of month, day of year, is Independence, is Xmas, is New York. So you have all of those columns of data. So now what we're going to do is we're going to do a box plot on the hour. And so you can see that the energy consumption is lowest in the early mornings, and it's highest in the evening. So that's interesting. So that's just telling you that when people are sleeping, they're not consuming as much energy. But when they get home from work and have their dinner, they're fixing their dinner and watching TV and washing the clothes, they're consuming more energy. Now we're going to do a box plot of the day of the week. And you can see, I believe 0 is a Monday. So 5 and 6 are going to be Saturday and Sunday. So 0 to 4, that's Monday to Friday, your energy consumption is pretty stable. But Saturday and Sunday, you have less energy consumption, and that's because people aren't going to work. So now we're going to do energy consumption for the month. So you can see you have more energy consumption in the winter because you're having to heat your house because it's cold. Less energy consumption in the spring and the autumn, because the weather is more temperate and you don't have to spend as much money on heating. And then in the summer, you have more energy consumption as well because it's hot. So a lot of people are going to use air conditioning. So we have seasonality, whereas you have higher energy consumption in the winter and the summer, and lower energy consumption in the spring and the autumn. So now what we're going to do is we're going to do a box plot on the quarter, so you can see that you have higher energy consumption on the first quarter and the third quarter, and lower energy consumption on the second quarter and the fourth quarter. So that just tells you that the first quarter is the winter, so people are going to be spending money to heat their house. The third quarter is summer, so people are going to be spending money to air conditioning. And then the second quarter is autumn, and the second quarter is spring, and the fourth quarter is autumn. So people aren't going to be using as much energy to heat and air condition their homes, so they're going to have a lower energy consumption. So now what we're going to do is we're going to define our training and our testing data sets. So we define the variable y, which we need to do when I plot a graph, because my program failed to save because I hadn't defined y. So we need the y when we plot our graph. And train equals PD data frame data 2002 1231 to 2014 1231. Test equals PD data frame data 2015 0101 to 2018 0102. And then we're going to set our features. So the features are going to be all of the columns in data excluding energy MW. So your features are hour, day of week, quarter, month, year, day of month, day of year, is Independence, is Xmas, is New York. So Y train is going to be train energy MW, and X train is going to be train features. Y test is going to be test energy MW, and X test is going to be test features. And then we check the shape of X train, Y train, X test, Y test to make sure that the data frames are what they should be. Now what we're going to do is we're going to normalize the data sets, and we're going to convert all of the cell values, all the cells, to a value between 0 and 1, and so that's the formula for normalization. We had to do that for X train and X test. And now we're going to define model. Model equals XGB.regressor, in estimators equals 1000, early stopping rounds equals 50, model fit X train, Y train, eval set equals X train, Y train, X test, Y test, verbose equals false. If you want to see it print out, then you can do verbose equals true, but I didn't want to see it print out for this purposes. And then print model.score X train, Y train. So you had 84.5% accuracy when you trained and fitted the data into the model, the training data. And now what we're going to do is we're going to predict on the test set. YPred equals model.predict X test. Print model.score X test, Y test. And so we had a 62.86% accuracy, which wasn't as good, but it wasn't horrible either. Now we're going to calculate our error. MSE, that's mean squared error, equals np.square, np.subtract, y test, y pred mean. And RMSE is root mean squared error, and so it's math square root MSE. So your root mean squared error is 627. So now what we're going to do is we're going to compare the predicted and true values, and then that way you can see how the predictions compared to the actual values. And then now what we're going to do is we're going to plot a graph. So you can see all of the graphs are around, close to the values, the true values. It's not horrible, it looks really neat if you think about it. If you think about how it's presented on the graph. And there are some things that we could do to improve the score, like hyperparameter tuning. And so that's the next thing I'm going to do, is see if I can tune XGB regressor hyperparameters to improve the score. But I just wanted to do this code review for the basics, so you can see how to do it. And my code is made available to the public, so you can look at my code if you want to, and I will leave a link to my code in the description box down below. So thank you so much for watching my video. Thank you for my subscribers who support my channel. If you like my video, please like, subscribe, and share. And I look forward to making more videos for you in the future.